Okay, so now it's time to welcome our next speaker. He is Mr. Hemant. He is Director Software Engineer in Mastercard. So Hemant has 17 years of industry experience in working with multiple clients in different domains, solving different business problems by appropriate technical solutions. Today he will speak on the topic Kickstart Your Understanding of Machine Learning with Python. So over to you, Hemant.
Yeah, so just a small introduction. I'm Hemant. I work with Mastercard as part of like a data engineering group, where we, get the data from multiple sources and ingest the data, which is like data has become like a big deal nowadays to get the insights and all that stuff, which we already know. So before I really start this session, right, a few points I would like to make here. As you see, the title is like Kickstart Your Machine Learning with Python. So this in this session for next like 20 odd minutes, I'm sharing my personal experience here, right? How I got started and some of the things which I learned. And I think if I did it, then a lot of people can easily do some of these things. So I'm just sharing my personal experience, and that is where you'll see this like a very basic terms. I have not used any of the big technical jargons or big fancy definitions or examples. I've tried to keep it as simple as possible, giving like very simple definitions and very simple explanation and use cases. That's my agenda, just to generate some sort of curiosity and motivation, and maybe few steps if from audience the people can take, and then they can start their machine learning journey. So with that, I will go ahead into the agenda part. So yeah, it's going to be like we'll talk a little bit about machine learning. Again, some simple definitions on like how what is a machine learning, what are different steps involved in machine learning, right? There are different steps we have to actually perform before we can say, okay, we are ready for the prediction. And some of these steps, what we are going to see, how we can do it in Python, like how Python makes some of these things easy, right? By no mean I mean like there are many other tools as well as R and some other languages, but just because I have some experience with Python, so I'm just sharing, as I said, I'm sharing my business, my journey here. So with that, I'll jump on to the next slide, which is like, what is a machine learning? Again, I'm using very simple definition. So machine learning is basically predicting outcome of a business problem, right? We are predicting something. We are predicting an outcome of a business problem by feeding business data. So it's not that in the machine or in computer, if I say, okay, this predict the sales of my store, or something else, then something is going to come out. So machine learning is a field where you're feeding data, and the whole process is based on how good your data is and how you are actually which algorithm you're using, and how you're manipulating, or not manipulating, but actually preparing your data to be fed. So business data is very important. So predicting outcome of a business problem by feeding business data into computer algorithms. So we'll look at some of them, like what is an algorithm. It's like a set of procedures which are like very specialized software which can take the data, analyze the pattern, and then predict the outcome or solve the business problem for you, which you are actually trying to solve. So with that, I'll just elaborate a little bit on what I mean by business problem here, right? Sorry, yeah. What do I mean by business problem? And before I go into that, um, So actually, again, business problem and or machine learning can be categorized into number of different streams. At a high level, I'm trying to keep it simple that a business problem could be supervised or unsupervised, right? What is supervised? Supervised means I know what is what I'm trying to predict, right? What exactly I'm trying to predict is something I know beforehand. For example, predicting the sales of my store, or predicting this customer will churn or leave my bank, or my store, or whatever those reward or telecom, in telecom domain, will this customer churn or not? Or it could be like predicting a demand supply. So that kind of things where I know what I'm trying to predict is called supervised machine learning algorithms. And the next is unsupervised, right? In unsupervised, I don't know what exactly is going to be the output, right? Let's say if I what I want to do is take all my customers and then try to create some sort of segmentation, right? So I don't know based on the data if my machine learning algorithm is going to give me like two segments, three segments, like high, medium, low kind of segments, or maybe like multiple segments on that. So something like that, which I don't know what exactly is going to be the output. Another example could be like, let's say we want to detect an outlier. Let's say I'm like a corporate where sales of all my stores are coming in, and I just want to see that are there any the data which I have received, are there any outliers? That means somebody due to whatever reasons that sales is like very low or very high. I don't know, right? If I know beforehand, okay, 2% variation is okay, then it's fine, right? But I don't know, maybe it's a season, maybe something else. So if I want to develop a machine learning algorithm to find out the outliers, then I don't know what exactly is the percentage of outliers. So that is another example where we can say that okay, this is a unsupervised machine learning algorithm. So again, your business problem could be in supervised or unsupervised, depending upon what you are trying to solve here. Now next, so as I said like a couple of times now, where machine learning algorithm needs data, right? So you have to actually feed data into these algorithms. So what is data? Like what should I actually feed into these machine learning algorithm, right? It could be anything. Let's say if I'm predicting the sales, then I can feed in like what has been like historical sales for the last few years, and some other details like what kind of customers, footfall, seasons, maybe customer profile, maybe some reward programs going. All that kind of information can become my business data. So business data is very important for any machine learning algorithm, because it actually the algorithms actually work on identifying the patterns, and then based on that they come up with the prediction. Now next thing, the important thing we learned in that definition was that computer algorithm. So I think I already mentioned that these are specialized software, and we'll see in Python how we can actually easily call which algorithm I want to use. I'm not going to like design the whole algorithm and then feed my data into that. So these are like very specialized software or computer programs which are actually available as in the form of libraries in Python and maybe in other languages as well. I think as a machine learning engineer, the biggest thing is how do I understand my data, which algorithms to use in which kind of problem to solve. That those are the things which I as a machine learning engineer I have to learn those things. So with that, I'm going to move into what are the steps involved in machine learning, right? So the first step is like exploratory data analysis, EDA is called. this is like a vast field, right? What is what is happening here in data analysis? So let's say, for example, if my business, like I'm a machine learning engineer, and my business is giving me data with, I don't know, maybe 500 attributes or features, we may call it, or like 1,000 attributes or features. And what am I going to do? Like, should I just go and feed that into the algorithm, which I think is going to be the right fit? Probably not. I think that's not what a good machine learning engineer would do, right? So that's where the exploratory data analysis, or EDA, comes in. So some of the steps I can, at a very high level, say what an EDA would involve, right? Let's say, as a machine learning engineer, I got the data. I should be looking at the quality of data, right? First is like completeness of data. Is that like all the, or most of the features have like null or empty or blank values? If that's the case, then what is the use of feeding this data into the machine learning algorithm? So we'll look at the data, and in some cases we may have to enrich the data here. Enrichment could be as simple as populating those fields, or the empty fields, with either, maybe, let's say if it's an age or a salary, maybe with like average salaries, right? Or maybe if it's a attribute type, then maybe it could be like mode of that. So it could be mean, median, mode, average, and many other methods could be like to enrich that data. So that's just one example, right? What what actually a machine learning engineer would do in this step as an EDA. There are a few other steps, if I may talk about that. It's like, okay, where you look at the quality of data, you look at the maybe correlation of these features, right? Does it, what I said is, like, if I have 1,000 features, does it really make sense to have all 1,000 features going inside the training, sorry, inside the machine learning algorithm? Maybe not. Maybe I should look at the correlation of these features with each other. I should be looking at if data has a lot of outliers, right? That is also a problem. And what if the data, let's say it's a customer churn data, which we will look at in few minutes. Let's say that data has only the customer who have churned, then I don't know, right? I mean, or the machine learning algorithm, if I feed only one type of data, it will not know what are the patterns in which customers have not churned. So so there are many steps which machine learning engineer would do in the first step, which is exploratory data analysis. And the good news is Python has like functions and methods to do some of these things very in simple way. Like, you can draw graphs and charts and histograms and many other models, and to actually visualize your data, and then take some decisions that, do I have to normalize this data, or do I have to enrich this data, or do I have to drop some of the fields because they are nowhere correlated to each other, and that kind of decisions an ML engineer or the machine learning engineer would take in the first step, which is exploratory data analysis. Now the next thing is training your model, right? As I said, what is a machine learning? It is actually predicting the business outcome based on the business data we are feeding into these computer algorithms or the machine learning algorithms. So for that, once my data is prepared, I have to feed the data into this model so that this model can learn the patterns, or based on the historical data, it will learn the pattern. It will draw some analysis out of it, that okay, if this is like this, something, these features are there, then maybe I should predict this, or something like that. It's going inside the algorithm is a complex stuff, but we have to actually train this model. Now training a model is not as simple as what I'm saying, right? Because there are sorry, there are many things, let's say what problem we are trying to solve, right? That would need, so there are many techniques on how do I choose the data, like which data should I use to train the model. For, if I give an example, in case of like fraud detection algorithm, right? No matter how much data you get, the actual fraud, where the fraud is happening, that would be less, right? Will be very small. That population or the universe will be very small as compared to non-fraud. So you will use a different technique for this kind of technique to choose the training model, in this case of business problem which you're trying to solve, or in cases where your data volume itself is very less. There could be few cases. So what technique should you use to actually choose the data, which data I should be using to train the model? So those are the complexities a machine learning engineer would know. Again, Python has functions which help you do all this in a simple way. But as a machine learning engineer, I have to know, like, okay, for which this business problem, this is what I have to choose, and all that stuff. And the last one, now we have actually looked at the data, we have completed our data analysis, we enriched the data, maybe we dropped some fields, we added new fields, we changed some of these features or attributes, we trained the model. Now what? Now I have to actually test the accuracy part of it, right? Is this model really giving me the output, or what exactly is it's going to give? So remember, in train model, that's the second step. We did not use the entire data to train these machine learning algorithms. We will keep some of the data. So if I give a very simple example, let's say I have 100 records, so maybe 70 I will choose to train the model, and 30 I would say, okay, let me take, once the model is trained, and we'll look at Python code in few minutes. Once my model is trained and is ready, then I would feed the test data and tell my model to actually now go and predict, and then I can um, compare the predicted value and the actual outcome what was there, and look at the accuracy of the data. And there are many other ways, like I put it in a very simple term, but there are many ways by which I can, or a machine learning engineer will actually look at, or find out the accuracy of the data model, or sorry, machine learning model. And that is very, very important, because I don't know if what my model is predicting is right or wrong. And in some of the cases, like predicting an accuracy itself is like another field of discussion, where what is important for you, right? What in some cases, let's say a false positive could be very expensive, or as compared to a false negative. Like for an example, if my algorithm, looking at the basic test, it predicts that a person has cancer or not, then false positive is still okay, right? If a person is diagnosed that, okay, he or she has cancer, then okay, that person will go for further test, and then they find out, okay, it doesn't have cancer, which is fine, good. But what if a person who actually have cancer but was not detected? So that's a very expensive mistake which this model will make. So depending upon what your model is trying to solve, there are many different accuracy techniques which can be used to actually test the model. I actually wrote a small blog in the Medium as well, on how you actually, or what all methods you can use to actually train your model. So yeah, so we actually got the data from business. We, as a machine learning engineer, we did all the analysis, enriched the data, found out all the right features or attributes to be fed into the data model. We employed or used one of the techniques to choose the training data. We trained our model, and then we tested the accuracy of our model, and that's where we can say, okay, our model is ready for predicting now. So in next few slides, we'll look at how Python is making some of these things very simple. Again, there are many different learning languages available. For example, R, SAS as a tool, and many others. I'm just talking about Python. How Python is making things easy, right? So the data I have taken is just downloaded the customer churn data from Kaggle. Kaggle is one of the websites, which provides a lot of machine learning exercises for free, and there are competitions. One can actually start the learning journey with Kaggle as well. So I just downloaded customer churn data. So if you can see Python, just three lines of code, I could ingest my data into Python data frame. So Python data frame is just one of the Python data structures. So what I'm trying to say here is Python has a lot of predefined libraries. So all I did is I imported this pandas library, which Python has. Python is a object-oriented language, and we know, right, we can import libraries and use its function. So simply I imported this panda. I just used its read underscore CSV function, and I ingested the data into this data structure, which is called pandas data frame. This file could have been JSON or Excel or something else, and there are many other functions which Python or pandas provide to ingest the data. And simply with another 3 words, I could see, okay, the data is inserted. Some of the other things, like as I was saying, I'll have to, as a machine learning engineer, I will have to actually look at the data, do some analysis. So if you see here in this line of code, just with churn data, which is the data frame where data is ingested, which is described, it provides me so many different things about the data, right? Count, mean, standard deviation, median, minimum amount, maximum, not amount, sorry, minimum value, maximum value, first quartile, third quartile, second quartile, like that. So many values Python is providing with, like, very minimal coding I'm doing here, but it is providing me a lot of values. Another example could be, as I said, I could draw some charts like this simple one-line statement. What I'm doing is the customers who have churned, like yes and no, versus their how many customer service calls they have actually made. So here I can see people who have made more number of calls have actually left the company. It's an example of like telecom domain. So people who have, or customers who have made more calls have actually left, which means that number of customer service call is a very important feature or attribute which should go into the machine learning model. And the last one, in the interest of time, so you can see here also you saw, right, okay, I imported some more libraries to actually draw these charts, right? So then after that, as I was saying, right, I don't have to write the algorithms, right? This train test split, this library or the function just helps me split my data into the training data and the test data, right? This sklearn model, I'm running this logistic, so where we have to predict like yes or no, is called a logistic regression problem. So I just imported this, and I'm using it here. So I created this data frame, ingested the data, I created a copy of this data frame, I copied all the attributes except the outcome, right? I just said drop this column, and in this data frame, I have all the attributes. So let's say 100 attributes were there, except the outcome. I copied 99 here. Then because this is X, Y is the prediction and X is the input, right? So this customer data churn, which was the output, I copied here. I using this train test split, I just split my data into X, which is going to be input, train and test, and Y, which is going to, so X is train, X train, Y train will be used to train the data, X test, Y test will be used to test the model output. So again, this I kept it very simple. There are more steps involved in EDA. For example, we cannot have attribute kind of data or the character set data. We have to actually convert that into numerical format, and there are ways again in Python we can do it. So if you have people who already know machine learning, they'll say, okay, man, this code is not going to work. It'll actually give you an error, which is correct because I have not performed a lot of other steps. So by no means I'm saying it is that simple. But my goal was actually to just um, give small input that okay, how Python can make it easy. Of course, machine learning is a big field. A lot of data science, statistics knowledge is required, mathematics knowledge is required, and data knowledge is required. So by no means I'm trying to make it simple, but my idea was that okay, whatever I can give in 20-25 minutes, saying okay, this is what a machine learning is and this is how you can actually get started. That's all from my side.
Yes.
Any queries
So
I can
thank you, Hemant. Thank you for your presentation. So
Mhm.
we are in the quiz session now, ladies and gentlemen.
Sure.
Please unmute yourself and go ahead with the query. This is the certificate of honor, Hemant Chadda. Thanks. It's a token of thanks for your valuable insight and valuable time. Thanks for joining us and presenting here.